Today we're going to continue with part 2 of our data visualization lectures. This follows from last week's previous lecture. And today we're going to focus on a few general principles that that will help us think about what makes for a good data visualization. And we're also going to dig a little bit deeper into the technical aspects of kernel density estimations, as well as some algebraic transformations that we can do on data in order to linearize relationships, which is something that both we tend to confirm visually and that is useful as part of the modeling process that we will come to next. So the first of these general principles that we'd like to discuss is the principle of scale in the data. So when we look at data, we should think very carefully about how we are representing the scale. We're going to illustrate that with this case study that is based on data from the Planned Parenthood organization. In 2015, they were accused, and there were congressional hearings about them selling aborted fetal tissue for profit. And Congressman Chaffetz showed this plot, which had appeared in a report from an organization called Americans United for Life. And I would like you to pause the video for a second and think about what are the issues with this plot. What is it showing? What message is it trying to convey? And is there anything amiss about it? Well, if we look a little bit at this figure, we see that the vertical scales are completely different. We're showing in here two different types of services provided by the Planned Parenthood organization. They provide abortion services and they provide cancer screening services. And this is showing a comparison between what happened in 2006 in terms of how many services were provided and 2013. But if you look carefully, these 2 points cannot possibly be on the same vertical scale. This is 2 million and this is 300,000. This is 290,000 and this is 900,000. So obviously these 2 vertical scales cannot possibly be the same. So it doesn't really make any sense from a good data visualization perspective to be showing these 2 lines as if they were lines that correspond in the same XY coordinate space. So if you recall, last week we said that in the previous lecture we said that data visualization can be used both as an exploratory tool when you yourself are trying to understand your data and as a sort of more editorial tool to present a message. And this is a great example of someone who made a very strong editorial choice and probably went a little bit over the top, because in this case the use of these 2 different scales is meant to give a reader who may look at this plot and not carefully think about what's happening with the vertical scales the impression that in this period of time the total number of abortion services has become much larger than the total number of cancer screening services, and that is actually not true in the data. So when we said that when making choices of visualization to communicate to others, you need to be careful and mindful of whether those choices are simply editorial emphasis, if you will, on the message you're trying to convey, versus crossing a line where you're actually presenting something that isn't supported by the data. This is a great example of visualization that by using 2 different scales for the same axis is effectively conveying something that isn't really there in the data and is a misleading visualization. So this is one way of showing those same data basically on the same vertical scale. In addition, since we're only comparing 2 points in time, we've also removed all of the other x-axis points. Now, it is true that cancer screenings did go down between 2006 and 2013, and that the number of abortion services did go up by a small amount. But it is not true that those 2 lines cross in terms of the total count. Now, if one wants, for example, to show these relative increases and decreases, then it would be much more appropriate to show, for example, the percent change in these types of procedures, and to show what the percent change, the fact that abortions went up by more than 10%, and that cancer screenings went down by a little bit over 50% in that period. And that definitely is a contrast between what happened to these 2 services between those 2 points in time at Planned Parenthood, which is faithful to the data. Now, another way to explore these data would be to, for example, visualize, if we have access to the total number of procedures performed by Planned Parenthood, to visualize how these services were part of the total number of services provided by Planned Parenthood in this period of time. And so, and here, by normalizing by the total number of services, we see that abortion services in between 2006 and 2013 became a larger fraction of the total versus cancer services, which went down. And finally, we want to make sure that the scales we choose reveal all of the data. So we want to choose axes that fill the visualization and show us all the data. But if it's necessary, for example, because the data has structure at multiple scales, because, for example, there's structure at this value, but perhaps in your data there's also important structure to be visualized that has a very different scale. There's a few options that you can choose. In this case, for example, we don't really get to see much of what's happening here. One possibility is to present these in different panels where you convey to the audience that different scales are being used. Another possibility is to use logarithmic scales that tend to compress the dynamic range and show variations differently, though they do introduce other distortions. But this is one way, this would be one way, for example, of better illustrating what's happening here by plotting only this part and perhaps including these parts of the data, if they're meaningful, in small sub-panels arranged on the side.